Hello everyone. Welcome to our webinar, which is broadcast every Thursday at 11 a.m. I am Serhat, and this week's webinar topic will be fire detection systems in industrial facilities. Today's subtopics are AIM, industrial facility types, industrial hazards, analyzing hazards, technologies used in early detection of hazards, fire and gas detection technologies, explosive atmosphere fire and gas detection, regulations, and application examples. The aim is to contribute to knowledge of the authorities who produce projects for industrial facilities. They implement applications and work in enterprises by briefly emphasizing the risks in industrial facilities. By presenting information about the technologies used in the early detection of these risks and their use. First of all, what's an industrial facility? Making raw materials or semi-processed materials ready for use is called industry, and areas and structures used for this purpose are called industrial facilities. In this webinar, information about the risks of combustion and explosion in industrial facilities and the use of early detection technologies were compiled. If we give an example of industrial facilities, those are petrochemical plants, woodworking plants, cotton, textile plants, paper plants, plastic plants, mines, energy production facilities, metal working plants, food processing and production facilities, treatment plants, and energy protection facilities. And what is industrial hazards in industrial facilities? Fire, explosion, and poisoning. One of the biggest mistakes made when designing a fire and gas detection system in industrial facilities is to rely on the architectural project. If only the architectural project is taken as a basis, it can be said that we should use a beam detector in an industrial facility with high ceilings. But the height of the environment and the materials that will explode in the environment are great of importance. First of all, explosive and toxic chemicals in industrial facilities should be analyzed. With this analysis, which chemical is present at which point of the facility? Which chemicals contain explosive or toxic gases? It's necessary to make a design to prevent dangerous chemicals or possible fire risks at the points mentioned in this report. Along with the hazard analysis report, a site of classification of the facility must also be made. Site classification is made as Zone 0, Zone 1, and Zone 2 within the framework of ATEX directives. If it is an explosive environment, the appropriate product should be selected. In the life of these data, fire and gas detection systems are designed according to architectural project, hazardous chemicals analysis report, and site classification. In this analysis, identifying hazardous chemicals, identification of hazardous properties, identification of effects on health and environment, identifying dangerous events or situations, and existing and potential hazards in process, storage, and handling areas need to be identified. The following information is required for appropriate electric material selection in hazardous areas. Class of the hazardous area, the temperature class or ignition temperature of the gas or vapor concerned, where applicable, the gas or vapor class associated with the group of or subgroup of the electrical material, external influences, and ambient temperature. After this information is obtained, The minimum conditions that the device to be used in the hazardous area must be meet will have emerged. This information about the devices is shown with the help of the numbering and signs on the labels of the devices, and also indicated on the catalog pages on the devices. When choosing the gas detector to be used in an explosive environment, the suitability of the environment to be hazard class, the group it belongs to, the ambient temperature, and the gas group to be detected must be checked. These controls can be easily achieved with the ATEX marking of the device. There are three types of marking label. First of all, surface temperature. When there is a spark explosion inside the detector, how much warmth it gives if there is a flammable gas in the environment where the detector is located. This temperature value may cause these gases to burn or explode. Therefore, the surface temperature of the detector to be used in the environment is important. For example, to detect a gas that explodes at 135 degrees, the surface temperature of the product we recommended shouldn't exceed T5. In case of an explosion, the T5 type product is maximum. It gives a temperature of 100 degrees, which doesn't pose a danger to the gas exploding at 135 degrees. Second of all is type 1 protection. It means intrinsic safety. The electronic circuit of the devices with type 1 protection doesn't create a spark due to itself, but an arc may occur in the voltage surge that may from external effects such as supply source or communication source. Possible danger is averted. Third and the last one is D-type protection. That is flame-proof enclosure. There is no need to use the Zener barrier in the D-type protection product because the D-type protected product doesn't leak out to explosion in any impact that may come from the voltage source. Thus, we can protect the explosive atmosphere directly with the D-type product. These are project principles of industrial areas. Reference is made to this standard in Article 75 of BYKHY. The following paragraph is also included in the introduction to the standard. The recommendations contained in this guide are not mandatory and do not have direct enforcement. However, it can be made compulsory by specifying it in a mandatory document. For example, a competent authority under local or national legislation may require compliance with this guideline. Or compliance may be required in a contract between buyer and a supplier. Detailed methods of making recommendations mandatory are not specified in this document. And this is a matter for organizations with the necessary mandates. These are also the standards of hazardous atmospheres and hazardous areas in industrial facilities. Legislation may apply where it is necessary to install fire alarm equipment in areas where there is a potential danger of flammable gas, dust, or vapor explosion. Attention is drawn to requirements of the ATEX directive for places with potentially explosive atmospheres. Any special hazards that may exist in the location of the equipment must be considered. For note that, for locations with potentially explosive atmospheres, the requirements of the ATEX directive are taken into account. Special risks are those that require special attention and knowledge in design and selection of the equipment, the placement of detectors and between them or the arrangement of circuits. These are electronic data processing areas, high bay warehouses, high ceiling areas, hazardous areas, and outdoor risks. And let's talk about a little bit application examples of industrial facilities. This project on the screen is water wells project in Kuşadası and Milas in Turkey. If we look at the emergence of the project, there are 5 to 6 meters wells going underground in Kuşadası and Milas. And these wells have building above ground. There are water pumps in the underground wells, and these pumps draw water from a water source that has been drilled with a pipe and passes under the ground, and the withdrawn water is transmitted to the city network. After a while, the personnel in charge of maintenance of these pumps open the door of the pump room and go down to the place where the pumps are. A rare geological events take place in that region, which is that as a result of some chemical movements that take place under the ground and the contact of these movements with water, carbon dioxide, hydrogen sulfide, and methane gases are released in this pump room. Methane is explosive and toxic, while hydrogen sulfide is immediately toxic. Personnel on duty to maintenance are affected by these gases and faint. Then other personnel get off and they are affected by the gas. Then third and fourth personnel in this incident, 5 people in Kuşadası and 6 people in Milas lose their lives due to these gases on the same day. After this event, we developed this project. There is a 4-channel gas panel placed in the front of the water wells and associated with 8 water pumps inside. And one of the 4 channels of this panel is carbon dioxide, the other is hydrogen sulfide, and the other is methane gas detectors. Under normal conditions, the doors are locked. If the chemical levels inside is at a normal level, the doors can't be opened. If it's not at a normal level, the door is not allowed to be opened. Our aim here was to implement a project which is explosive poisonous gas level inside is outside of normal. It's not allowed to enter inside. In addition, in this project, the data of these devices were monitored over the panels by using as many Modbus cards as the panel on which each pump is controlled. And the panels were monitored and controlled via supervisor. And this is another application example and another project for industrial areas. In this project, Vestel has a complex production facility and there are 2 factories in this facility. Methane detection is done in factories. In the project, it's requested that the detection system to be monitored from a center. There are 14 methane gas detection detectors in one factory and 67 in the other. And there are 8 panels in total which these detectors are connected. Here, as well as the number of panels, data were transferred to the fire alarm control panels over their own network using Modbus modules. And then the fire alarm control panels were integrated into the remote monitoring and control software to perform monitoring. Thank you for your participation in our webinar. Hope to see you in next week. And if you have a question, you can feel free to ask me from the chat box.